Hello there. If there's one thing we can agree on, it's that an e-learning day is fabulous. I caught on by the afternoon, but I didn't know in the morning. So sorry, second period students. Happily, the thing is the same. So there's still bell work even on e-learning day. Hi. Okay, so what you're going to do on your bell work for today is you're going to write down the numbers 4, 5, 6, and 7. So go ahead and pause and do that. If you don't have your bell work, you'll have to do this later. That's okay. Or you can do it on another piece of paper and then just transfer your answers. And so I want to show you, it might be hard to see. You might be able to zoom in on YouTube, but I'm just going to talk through this. So you're looking at a graph, a diagram, and some text. And the graph, the x-axis says year from 1970 to 1985. The y-axis says phytoplankton biomass in milligrams per cubic meter, and it goes from 0 to 8,000. There are open circles and closed circles. The open circles say treated with sucrose, and the closed circles say treated with sucrose and phosphate. Now, the blob-looking thing says Figure 1, phytoplankton biomass in two sides of a small lake divided by an impermeable curtain. And it says impermeable curtain. Maybe you don't know what impermeable means. It means that stuff cannot pass through it. Impermeable. In the early 1970s, researchers hypothesized that carbon was the limiting nutrient in many aquatic ecosystems. To test this hypothesis, the researchers divided a small lake in two roughly equal halves with an impenetrable curtain that was fastened and sealed to the bedrock on the lake. Beginning in 1971, the researchers treated one side of the lake with sucrose and the other side with both sucrose and phosphate. From 1971 to 1983, the researchers monitored the phytoplankton biomass in both parts of the lake, and the results are shown in Figure 1, which is up here. Okay, sorry it's blurry since you can see the words a little better. So I'm going to ask for your best answers here. For which of the following claims is best supported by the data? A, carbon was a limiting factor for phytoplankton in the lake. B, phosphate was a limiting factor for phytoplankton in the lake. C, both carbon and phosphate were limiting factors for phytoplankton in the lake. D, neither carbon nor phosphate was a limiting factor for phytoplankton in the lake. And if this is your first time seeing limiting factor, it's like if you were trying to make brownies from a box, if you've ever tried to do that, and you have a whole bunch of oil, you have a whole bunch of water, but you don't have many eggs. And so the eggs are the limiting reagent to how many you can make those brownies. I make brownies without eggs. They're pretty good. So give your best answer and then move on. Number 5, the average growth rate of the phytoplankton population from 1971 to 1975 in the side of the lake treated with sucrose and phosphate is closest to which of the following? A, 125 milligram per cubic meters per year, and they're all in that unit. So A is 125, B is 1,000, C is 1,500, and D is 6,000. Go ahead and write your best answer. 6. Which of the following treatments would have been the best control treatment for the experiment? A, an untreated section of the lake. B, a section of the lake that was treated with phosphate but not sucrose. C, a different lake that was treated with sucrose and phosphate. D, a small pool of lake water maintained in a controlled laboratory environment. And number 7, which of the following was most likely a direct consequence of the addition of phosphate to the lake? A, the amount of biomass in the first trophic level decreased. B, the amount of biomass in the second trophic level decreased. C, the amount of energy available to producers in the lake increased. D, the amount of energy available to consumers in the lake increased. Pick your best answer. All right, we'll talk about them later. You can write same one more time. We're going to do an ecosystems project feedback cycle. This will be you having to be very careful about the instructions. If you still end up confused, Panther Plus would be an awesome place to get that support to help make sure that I can look at your diagram with you. So we're going to do this ecosystem project feedback cycle. We're going to finish the logistic growth interactive and the LGI worksheet, but not the last page. I don't know if I printed it for you, but not the last page. So, hey, we're going to come back to our guiding questions, thinking about how communities and ecosystems change due to biological disruption, thinking about how we can create repair and resilience. That's what your project is about. But now thinking about the acquisition of energy related to health, and then we've learned a little bit about species interactions. There will be more. By the way, oh, there's a type extra space in that first one. I collected all of the problems for this project that we're going to return to in earnest tomorrow, and they're really interesting. Like, what are we fighting? Like, why should others care? What could go wrong? What's the root of the problem? How did it start? How long has it been going on? What are stopping people from solving it right now? What are possible solutions? What's been done before? How does it work? How does it affect other parts of ecosystems or human wellness? Who will pay? Like, what's the budget? Who will pay? I just mean like, where's the money going to come from for your solution? Is it local? Is it global? Who are stakeholders? What are researchers learning right now? What role, if any, did humans play in making this problem worse? Who are the people who could best make the change? Is new technology available? And like, what causes new people or what causes people to follow a law? So, will you please take a moment and find your ecosystem project? There are two places where you might find it. You should find it, a picture of it at the bottom of your digital submission, or you might have the paper in hand. Both are okay. So remember, we talked about how you're going to be drawing diagrams that have a lot of moving pieces, and really specifically, just like the yellow and green lines here, you're going to have a lot of arrows where they're like multicolored or like up here in this part of the diagram. So like there's going to be some places. This is like downtown. It's really nice. Okay. So here is a very competent current student's ecosystem diagram. And I can't really see yellow. I don't know if you notice about me. I can see a little bit of it here, but I can't really see certain colors of yellow or dark blue. So I can tell that there are some yellow arrows that are coming down from the sun and that I think they're going from the producers into the consumers. That's great. We are seeing some water cycling here, and I think we're seeing the beginnings of the carbon cycle and the beginnings of the nitrogen cycle. This is a really good first start. It's got, I think, some decomposers. I don't remember where they are right now. They're there over in the corner. This is a good first start. It still has a way to go. Sorry, beloved student, if this is you. Here is somebody else's. So now you can see the beginning. You are also beloved. Now you can see the beginnings of drawing multiple arrows. So I'm pretty sure that this arrow is both yellow and red. Red for carbon. Now is carbon coming in from the sun? No, but did this person draw it from this moving this way? Perfect. That's a great fix for that problem. So now you can see that the energy and the carbon is moving in this arrow, and it's moving to become what I think is a rock or microscopic organism. But it's missing. Maybe there's a red arrow here, but there should be if there's not. So the microlites that are being eaten and feeding the brine shrimp, there should be a carbon arrow there as well. I see there's an arrow here saying energy is lost as heat. That's pretty great. This one's still incomplete, and it's incomplete for a couple of important reasons. This one's closer. So if this is you, hey, you're getting closer. So we've got here the producers down here taking in energy. This is a sea cucumber. Where's seagrass? There it is. Taking in carbon dioxide, but I don't see a yellow arrow coming up from the sun to provide the energy for this seagrass. What I do see is then lots of arrows going this way. I do note that I think we're missing an arrow. I think we're missing a green arrow here because all of the nutrients are in the seagrass and they're being eaten by the urchin. And there's a similar problem with all of these. So it has a lot of the arrows, but I think it's missing a color of arrow. And I think, hard for me to tell with my brightness down, but I think that color is green. So all of these are good examples. They're just still in progress. So let me remind you first about something a lot of the ones I saw hit, that you have an error. Well, let me just do it in written out format. So what you're going to do is find a piece of paper or like write directly on your diagram or type some notes in the bottom of your digital submission, the Canvas thing that you submitted, the Google Drive. I'm going to get there. All right, ready? So you need to have a yellow arrow from the sun to your producers. That's like that's where energy comes from. You need to know that. And then that yellow arrow goes up through the food web. If there's an organism that's eating, it's obtaining energy from the eating, right? And then every living thing, the waste and the decomposing bodies get decomposed by decomposers. So you need a yellow arrow to decomposers from every living thing. And that includes decomposers being decomposed by living decomposers. That's tricky. Yeah. But also, I'm thankful. Decomposers are important. Otherwise, we would be swimming in a sea of dead ants. So, feel happy about that. And then the other piece that we looked at in one of these is that every living thing loses heat. So you've got to have an arrow coming away from every living thing out someplace into the general atmosphere for heat. Atmosphere, I'm like dirt, wherever it is, ocean. And then reminder, arrows point into the organism doing the harvesting of energy, just like me looking at a carrot and putting it into my face. Love eating carrots. Okay, now the next order of business is the water cycle. So this is a traditional picture of the water cycle, but what you're not seeing is that plants contain water. So you need the water arrows to be present throughout the food chain alongside the yellow arrows. And the same is true for carbon. The same is true for nitrogen. Oh, is nitrogen, sorry. The same is true for phosphorus. You get all of these things through eating. Do you drink water separately? Yes. Many organisms do not. And so even when you eat like something that feels other than like jerky, if you're eating a food that has not been processed, it probably has some water in it. It does have some water in it, and you are using that water. So you need a little water cycle. You need to show me some precipitation in this assignment. And also, there needs to be a blue arrow every single place there is a food chain arrow, right? You're also breathing out water, but you don't need to put that out. That seems like a lot. You're good. That is what like fogs up a mirror when you blow on a mirror, like on a mirror or something. So anyway, you need to do the same thing for the other colors of arrow in addition to showing the reservoirs of the carbon cycle, which is most of the atmosphere, the reservoir of the nitrogen cycle. Many people showed that this is happening in the soil, and they got this idea about bacteria making bioavailable nitrogen for plants. That's really important, that bacteria are turning nitrogen. They're taking nitrogen from the air and they are fixing it, and then that's what's making it available to plants. Decomposers are also doing a good job. So those two need to be in your nitrogen cycle. And then in your phosphorus cycle, it really is about phosphate rock that then gets like ground up, and that's what's in the soils that allows phosphorus to continue. That's it, phosphate, but I meant phosphorus cycle. So one more time, you need to have an arrow alongside yellow arrows for all of these, plus this particular situation. So to correct and resubmit, you have two choices. You can draw the correct arrows on your diagram. If that is what's going to bring you joy, you can do it. But I'm going to give you another option. If you have done a diagram that is at least as put together as this person's, where you've got rainbow arrows, you need to add your whatever color we were missing. Oh, mate, there's a green one there. So it happens sometimes. Anyway, you have to add a little bit of arrows to this one, my friend, so that the green arrow is here, for example. If you have all of those, if that has happened, then you are ready to do the digital submission option. So at the bottom of your digital submission, you should type out a paragraph or bullet points that describe what you would correct and why. And by why, I don't want you to write, I forgot to add it, or I didn't understand the arrows. You need to say things like the arrows point into the organism that is harvesting the energy, or I don't know, phosphorus is being transferred when I don't know, a consumer eats a producer or whatever, right? And then you need to resubmit the digital assignment to Canvas by the end of the day. Note to Jiping, you submitted a black and white diagram, and I need it to be in color. So your computer will take color pictures for you. You can use camera, and it will do a pretty good job, especially if you set it to document. All right, so at the end of today, the goal is to finish the logistics growth interactive. So that is, my goodness, hang on. Hang on. Yeah, cannot handle the share. You can't handle the share. Here we go. So, nope, still no. Oh my goodness. There we go. So hopefully if things went well, you were down here someplace at the end of page 3. And so today we're going to look at some case studies so you can see some growth limits. I have case studies for you, and you're just going to go through that section. And after you've learned about all the case studies, you're going to go to the match mechanism to study section, and you're going to answer the questions, or you can mark your answers on the paper. It doesn't matter to me. Now, I wanted to show you that this is now linked directly in Canvas as well as in the assignment. And it's a document that has information about the case studies. So what you're going to do today is read the case study and look at the graph. Read the case study and understand the graph. You're going to do that for all of these. You do not need to answer all of the questions. You just need to take a look at those case studies so you have some examples. And honestly, we haven't read a bunch of graphs. So as you've noticed, this assignment is helping you do that. I'm going to read some graphs. Graph time all the time, my hearties. Okay. So once you're done with that, you do not need to do page 5. You just need to finish. Let me look really quickly, although I know you can't see. You just need to finish through question 18 on that assignment. Okay. Then that's going to go in the inbox when you come back. Now, in the cool down, you're going to write online on your paper. In a moment, I'm going to update Canvas with a cool down link for today in that same color of yellow. You're going to pick one of the case studies, you're going to read it, and you're just going to answer the questions in the Canvas text box, type it out. It's really important to me that this be your own work, not the internet's or AI's, and that you use complete sentences. I will wager this is a pretty old assignment from 2020, and so I'll wager that there are sample answer keys floating around on the internet. I just want you to be mindful that you need to practice doing this work because there will not be anybody to help you on the AP exam. And honestly, like growing your skills is part of what we're up to here. If it went really poorly, we'll fix it for you. So that's going to be done hopefully by the end of today, but it'll be open for the next little bit. I strongly suggest you do it though, so that you'll be ready to help get started on the project with your teammates or working independently tomorrow. We're going to pick that back up. So, all right, that's it for me. I hope you are doing well out there, and I'm excited to hopefully see you tomorrow. All right, take care.